So today we'll be looking at constructing recursive and explicit rules for a given geometric sequence. Markers of Japanese swords in the 1400s repeatedly folded and hardened the metal to form layers. The folding process increased the strength of the sword. The table shows how the number of layers depends on the number of folds. These are the number of folds, and these are the numbers of layers. To write the recursive rule, find the common ratio by calculating the ratio of consecutive terms. 4 and 2 are the first two numbers of the table, and 2 is the common ratio. You get the common ratio by dividing the first two numbers of the table, so the common ratio is 2. The common ratio is 2, so F1 equals 2. All the terms after the first term are the product of the previous term and the common ratio. So, to find F2, the second term, you would multiply the first term times the common ratio, and that would give you an answer. To find the third term, you do the same thing, but with the previous term to that. So the second term times the common ratio, and it goes on and on and on. State the recursive rule by providing the first term and the rule for successive terms. Fn minus 1 is the term you're trying to find times the common ratio. And that is pretty much what this is. Write an explicit rule for the sequence by writing each term as a product of the first term and the power of the common ratio. So that means to find the first term, you multiply the first number of the table, and like it's the first term, there's no term before that, so it's at the 0 power. And this is the first term of the table, the common ratio, and the power of the term before that. We generalize the results from the table. And these are the results. Fn is the term you're trying to find. 2 is the first term, and this is the common ratio, and the term you're trying to find, minus 1.